Now, the assignment was designed by a person, and I wanted to say that I'm not so happy about the question, and I need to make a little clarification here. You are given in your assignment a utilization factor. And really, and it's given this in the exercise I done for you, which is similar to the one you have in your assignment. I use this value for the utilization factor. So this is what you have, but in reality, you're given a dimensions for the room, and it is very clear that the height at which these lights are is going to have an impact in how much light you're going to have in the working surface. Now, this is a table here, and this is the working surface, and for the assignment, no, but for the question I have given you, I state that was 9.9 meters. And then I said that the room height, which is here, is 2.9 meters. Now, we also say the room to have 10 meters in length and 6 meters in width. Now, this information was given for a reason, and it's so you could use this information in order to work out your utilization factor. But it's given to you. So all this has no use in your exercise. However, I want to explain. Yes, there is a formula here, and that's to calculate the room index. Now, the room index is going to look at a formula where you're going to have the horizontal area. I'm going to put H as horizontal, and I'm going to put here area vertical. And that vertical area is times the height. Now, let's look at this horizontal area. Area horizontal is the area. You could say the area of the table, but I want to be able to put this table wherever I want in the room. I want to have the same amount of light everywhere in the room, not just here, and have these corners dark, which I could do, but I don't want. I want the whole room to be to have the same level of light. So what I'm doing is I'm going to work out the area, and the area is 6 times 10 equals 60 meters square. So that's the figure that goes here. Now, the vertical area is found in a different way, and it's area vertical equals, and this is a different formula because we're going to have the length times the width and times the height in meters. Now, that's where this information comes to use, because the height is going to be the total height of the building, of the room, which is 2.9 meters minus 0.9 meters, and that's 2 meters. Because I want to have certain intensity of light at a certain height, and it's the height of that table, not the floor, not elsewhere. I want the light in that particular place. If I put a light meter on this table, it's going to measure higher than if I put it on the floor, because there is a distance of 2 meters to the source of light on the table, and it's a distance of 2.9 meters to the source of light on the floor. So that makes a difference, and that's how it's worked out. So I'm going to put a AB, so that's a vertical area, and it's the length. And again, we are going to put 60 meters square, and this is times the height, and it's 2, and that is 120. Now, if we look at the formula, room index equals that over that, which is 60 over 120, and that factor will be what we are going to take into account in our calculation. Now I'm going to do this not by head. In my head I'm going to just do it in the calculator, and we got a 0.5, which is what we expected, factor, room factor. Now this room factor will be used together with other information, like for example reflectance of the walls and other things, to work out that utilization factor. Now you don't need to do this in your exercise because it's already given to you, but you've been given all this information and all these heights and all that, and I explained you these things not to stop there and not explain it to you. So I said in your exercise, lower the lights. Now I got a ceiling height of 2.9 meters, and I got these tables at 0.9 meters, and I got this distance here, 2 meters. Now if these lights are mounted there, yeah, the distance here is not going to be 2 meters, but let's say it's 2 meters. I'm going to put 2000 millimeters. If I was going to hang them a little bit lower with cables, like you do, it's not a big issue, you will have shortened this distance, so it will have made the light on this working surface bigger, because you shortened this distance. And that is why I said I'm going to keep 9 lights, and I suggest to make this distance shorter. Now this is not part of your exercise, it's me teaching and you learning, and this is the end of this tutorial. Next tutorial I'm going to be teaching you how to do the drawing.